Hello everyone, today we are going through product of two vectors. We learned addition of two vectors, subtraction of two vectors and multiplication of a vector by a scalar. In this section we will study product of two vectors. Here we know that product of two numbers or product of matrices is defined in only one way, right? But product of two functions is defined in two ways, that is pointwise and composition of two functions, right? So similarly, here also the product of two vectors is also defined in two ways. One is a scalar product, another one is vector product. In scalar product, multiplication of two vectors is a scalar. In vector product, multiplication of two vectors is a vector. Okay. So before that, here let's see what is the angle between two non-zero vectors. Okay. Let vector A and vector B be two vectors, non-zero vectors. See, look at the first diagram. Here, the angle between vector A and vector B is the angle between the directions. Okay. Angle between vector A and vector B is the angle between the directions. Here, direction should be converge to O or diverge from O. Okay, direction should be converge to O or diverge from O, a point. Okay, converge to a point and diverge from a point. Okay, see, look at the first diagram. Here vector A and vector B be non-zero vectors. So here what is the angle between these two vectors? See here, vector A and vector B are converge to O, right? Vector A and vector B converge to O, it is a point to O. Therefore, theta is the angle between them. Okay. Look at the second one. Here vector A and vector B diverge from O. Therefore, theta is the angle between them. Okay. What about third one? Here vector A and vector B neither converge to O nor diverge from O. Right? See, vector A is in this direction, vector B is the opposite direction, right? Therefore, here theta is not angle between them. Okay? So here let's see, it is vector A, right? So it's also vector A, that is in this direction. It's also vector A. Okay? Now see, vector A and vector B converge to O. Right? Vector A and vector B converge to O. Therefore, here the angle between vector A and vector B is this angle. What is this angle? It is theta. Okay? It is theta. Therefore, it is pi minus theta. Okay? Pi minus theta. And look at the fourth diagram. See, here also vector A and vector B neither converge to O nor diverge from O. So, here also we can see it is vector B, right? So, same this one also vector B. Okay? Same direction, right? So, here vector A and vector B converge to O. Right? Vector A and vector B converge to O. Therefore, here it is the angle between them. So, what is this angle? It is theta. It is 180, right? This angle, total angle is 180 degree. Therefore, it is 180 minus theta. That is pi minus theta. Therefore, in this third and fourth diagram, the angle between vector A and vector B is pi minus theta. Now we are going through scalar or dot product of two vectors. I have mentioned that product of two vectors is defined in two ways. One is scalar product and vector product. So now we are going through scalar product or dot product of two vectors. Let vector A and vector B be non-zero vectors. Vector A and vector B be non-zero vectors. Then dot product or scalar product of two vectors, vector A and vector B is denoted by vector A dot vector B. Okay, that is scalar product of vector A and vector B. Scalar product or dot product of vector A and vector B is denoted by vector A dot vector B, and it is defined as vector A dot vector B is equal to modulus of vector A into modulus of vector B into cos theta. Okay, it's very important. It is the dot product of two vectors. Okay, dot product of two vectors, vector A and vector B, is denoted by vector A dot to vector B. That is why it is called a dot product. Okay, so vector A dot to vector B is equal, and it is defined as vector A dot to vector B is equal to modulus of vector A into modulus of vector B cos theta. Okay. Here theta is nothing but it is the angle between vector A and vector B. Theta is the angle between vector A and vector B. Okay. Now here if vector A and vector B are unit vector, then what is the dot product or scalar product of them? Here vector A and vector B. If vector A and vector B are unit vectors, we know that if they are unit vector, their magnitudes are say 1, right? That is modulus of vector A is equal to 1 and modulus of vector B is equal to 1. Then what is the scalar product of them? That is vector A. Here since these are unit vectors, we can write A cap. Okay, A cap A dot B, vector A dot vector B is equal to modulus of vector A into modulus of vector B into cos theta. Right? Here, what is modulus of vector A? That is magnitude of vector A. Here, vector A is unit vector, right? Vector A and vector B are unit vectors. Therefore, their magnitudes are 1. Okay? That is modulus of vector A and modulus of vector B is equal to 1. Okay? So, here, therefore, it is equal to cos theta. 1 into cos theta. So remember, if vector A and vector B are unit vectors, then scalar product of vector A and vector B is nothing but cos theta. Theta is the angle between them. Okay. Now, what is vector A dot vector A? If vector A is non-zero vector. Okay. If vector A is non-zero vector, then what is vector A dot vector A? Vector A dot vector A. So what is the angle? 0, right? Angle between them is 0. That is vector A dot same vector, right? So angle is 0. So vector A dot vector A is modulus of vector A into modulus of vector A into cos 0. Angle is 0, right? What is cos 0? 1, right? Therefore, modulus of vector A into modulus of vector A, that is modulus of vector A square. Okay. Therefore, vector A dot vector A is equal to modulus A vector A square. Now, what is the scalar product of mutual perpendicular vectors? Suppose vector A and vector B are mutually perpendicular. Okay. Vector A and vector B are perpendicular vectors. Then what is the angle? What is the scalar product of them? That is vector A and vector B are perpendicular. Okay, perpendicular vectors. Then what is the scalar product? That is vector A dot vector B. Vector A dot vector B is modulus of vector A into modulus of vector B into cos theta, right? Into cos theta. Since they are perpendicular, what is the angle between them? 90 degree, right? Therefore, theta is equal to 90 degree. So, it is modulus of vector A into modulus of vector B cos 90. That is cos pi by 2, right? What is cos pi by 2? 0. So, this one will be 0. So, remember, if two vectors, that is scalar product of two vectors, perpendicular vectors is 0. Okay, if vector A and vector B are perpendicular, then their scalar product is 0. Now, let's take our unit vectors, vector I, vector J, vector K. Okay, vector I, vector J and vector K are mutual perpendicular unit vectors. Okay. Vector I, we know that vector I and vector j, vector k, components, right? So component vectors, and these are unit vectors and they are mutually perpendicular, right? So here vector I, vector j, vector k are mutual perpendicular unit vectors. Therefore, modulus of vector I is equal to 1, modulus of vector j is equal to 1, modulus of vector k is equal to 1. Their magnitudes are 1, right? Because they are unit vectors. Okay. Now, what is vector I dot vector I? I dot I. See, I dot I. What is the angle? 0, right? So, since here I dot I, according to the definition of a scalar product, here we can write modulus I into modulus vector I is into cos theta, right? So, here theta is 0. That is, I into I, see here what is the modulus of I? 1, right? So 1 into 1, it is 1. Therefore, I dot I is equal to 1. What is j dot j? That is modulus j into cos 0. J dot j, their angle is 0, right? Therefore, it is also 1. Similarly, k dot k is also 1. Okay? And what about I dot j? I dot j. Here we know that vector I, j, k are mutually perpendicular unit vectors. They are perpendicular each other. Okay. Therefore, I dot j, what is the angle between them? 90 degree, right? Therefore, I dot j is equal to modulus I into modulus j into cos 90 degree. Cos 90 is 0. Therefore, its value is 0. Okay. I dot j is equal to 0. Similarly, j dot k is also 0. Okay, because their angle is also, they are perpendicular each other, right? So, j dot k is also 0. And I dot k is also 0. Okay. So, here we know that their product that is dot product of two vectors is a scalar. That is a real number, right? Therefore, this product is called a scalar product. Okay. Next is scalar product in component form. Let vector A is equal to a1i plus a2j plus a3k, and vector B is equal to b1i plus b2j plus b3k. Then what is vector A dot vector B? Vector A dot vector B is equal to a1i plus a2j plus a3k dot b1i plus b2j plus b3k. That is equal to a1i, let's simplify this one, vector that is a1i into this vector, that is b1i plus b2j plus b3k, plus next is a2j dot b1i plus b2j plus b3k, plus a3k dot b1i plus b2j plus b3k. Right? Now here, see, when we expand this one, here a1i dot, okay, a1i dot b1i, that is a1 b1 I dot I. Let's take the constants outside. Okay, here a1 b1 are the constants, real numbers, and vectors I dot I, right? I dot I. What is I dot I? 1, right? Therefore, here we can write a1 b1 I dot I. Next is, see, a1i dot b2j. That is a1 b2 I dot j. What is I dot j? 0, right? So here we will get a1, next term will be 0, right? Because I dot j is 0. And third term, that is I dot k. a1 I dot b3k, that is a1 b3 I dot k. That is I dot k is also 0, right? So here in this first term we will get only one term. Okay, remaining terms will be 0. Right? So here a1 b1 I dot I, that is 1. So here we can write a1 b1. Okay, plus next come here a2j dot b1 I, that is here a2 and b1 real numbers, scalar. So here j dot I is also 0 and j dot j is 1. So here also we will get only one term, that is a2 b2. Right? Remaining terms will be 0. Why? Because j dot I is 0, j dot k is also 0. Right? Therefore, here we will get a2 b2. a2j dot b2j, that is a2 b2 j dot j. j dot j is 1. Okay? Plus, next, third term. Here, a3k dot b1 I, that is a3 b1 k dot I. K dot I is 0. K dot j is also 0. K dot k is 1. So here also we will get only one term, that is a3 b3. a3 b3. It's very important. That is scalar product in component form. Now we learned that dot product vector A dot vector B is equal to scalar product of two vectors, vector A and vector B is defined as vector A dot vector B is equal to modulus of vector A into modulus of vector B cos theta. Right? So here what is theta? Theta is the angle between them. Okay? So here we can write angle between two vectors, vector A and B. Here write this equation as cos theta is equal to vector A dot vector B divided by modulus of vector A into modulus of vector B. Now what is theta? That implies theta is equal to cos inverse, right? Theta is cos inverse of vector A dot vector B divided by modulus of vector A into modulus of vector B. Okay, that is theta, that is angle between vector A and vector B. Theta is equal to cos inverse of vector A dot vector B divided by modulus of vector A into modulus of vector B. Now here let's see what is the angle between two vectors in component form. Let vector A is equal to a1i plus a2j plus a3k and vector B is equal to b1i plus b2j plus b3k. Okay. Then what is theta? That is angle between them. That is here we know that theta is equal to cos inverse of vector A dot vector B divided by modulus of vector A into modulus of vector B. What is vector A dot vector B? That is scalar product in component form. That is a1 b1, right? a1 b1 plus a2 b2 plus a3 b3, cos inverse of, okay, cos inverse of a1 b1 plus a2 b2 plus a3 b3 divided by modulus of vector A. Vector A is equal to this one. So what is the modulus of vector A? That is square root of a1 square plus a2 square plus a3 square, right? Into square root of b1 square plus b2 square plus b3 square, right? So it is the angle between two vectors in component form. Next one is projection of a vector. What is a projection of a vector? Projection of a vector is the length of the shadow of the given vector over another vector. That is, projection of a vector is the length of the shadow of a given vector over another vector. It is obtained by multiplying the magnitude of the given vector with the cosecant of the angle between these two vectors. See here, see, suppose these two vectors, vector A and vector B. Okay, it is the point O, it is A, it is B. Vector OA is vector A and vector OB is vector B. Okay. See, I will make a triangle, right angle triangle. So it is the point here. Okay. So here it is the angle theta. That is angle between vector A and vector B. Here OL is the projection of vector A on vector B. Okay. That I told. See here projection vector is the length of the shadow of the vector on another vector. See, another vector is vector B. Okay. So here OL is the projection of vector A on vector B. Okay. Here we can write it is the angle theta, right? Angle between vector A and vector B. So what is cos theta? Adjacent divided by hypotenuse, right? That is OL divided by OA, right? So here what is OA? OL divided by, here OA, it is the vector A, right? What is its length? That is magnitude, right? So modulus of vector A, right? So take this modulus here. So here we will get OL is equal to modulus of vector A cos theta. Okay, then. Now let's see how to find projection of a vector on another vector. It's very important. Okay. See, we have a scalar product vector A dot to vector B is equal to modulus of vector A into modulus of vector B cos theta. Right? That is here vector A dot to vector B is equal to, see what is vector modulus of vector A cos theta is nothing but OL, right? So here we can write modulus of vector B and it is OL, right? OL. Here what is OL? OL is the projection of vector A on vector B. Projection of vector A on vector B. Okay? Here OL is the projection of vector A on vector B. So what is OL? That implies OL is equal to vector A dot vector B, that is scalar product of vector A and vector B divided by modulus of vector B. So by using this formula, we will find the projection of a vector on vector B. Here projection of vector A on vector B is vector A dot vector B divided by modulus of vector B. Look at the very important question. Find the projection vector of a vector B is equal to I plus 2j plus k along the vector A is equal to 2i plus j plus 2k. Also write vector B as the sum of a vector along vector A and a vector perpendicular to vector A. We know that how to find projection of a vector on another vector, right? Here we have to find projection vector of B on vector A. Okay. So here, see, here we studied that projection of a vector A on vector B is equal to vector A dot vector B divided by modulus of vector B. Right? It is the projection of a vector. It is a scalar quantity. Okay. Now, what is the projection vector of a vector on another vector? That is projection vector of vector A on vector B, that is equal to here vector A dot vector B divided by modulus of vector B into, here we multiply this by unit vector, that is B cap. Okay, that is unit vector along the vector B. Okay, so here we can write it as, see, B cap is nothing but vector B divided by magnitude, right? That is unit vector is nothing but that vector A divided by modulus of vector A, that is the unit vector, right? So here this can be written as vector A dot vector B divided by modulus of vector B into vector B divided by modulus of vector B. That is equal to vector A dot vector B into vector B divided by modulus of vector B square. Okay. So here it is the formula to find the projection vector of a vector on another vector. Okay. So let's find. Here we have to find the projection vector of B on A. Okay. Projection vector of B on A. Here it is the formula projection vector of A on B. Okay. Therefore, projection vector of B on A is equal to vector A dot vector B dot, here vector into vector A, right? Okay. Vector A divided by modulus of vector A square, because here we will find the projection vector of B on A. If it is on B, then in denominator modulus of vector B. If it is on A, then modulus vector A. Okay. So here let's find. So first of all, let's find scalar product vector A dot vector B. Okay, now we will find vector A dot vector B. Vector A dot vector B. Vector A dot vector B is equal to I plus 2j plus k dot B is, okay, it is B, it is A, okay, 2y plus j plus 2k. Here notice that vector A dot vector B, that is equal to vector B dot vector A, okay, because it is commutative. Okay, so here vector A dot B is equal to, okay, let's find the vector A dot vector B, that is A1 B1 plus A2 B2 plus A3 B3, right? So 1 into 2, 2 plus 2 into 1, 2 plus 1 into 2, 2, that is 6. So here we have got vector A dot vector B. We have to find projection vector of vector B on vector A, right? So here we need to find on vector A, right? So denominator is modulus of vector A square. So let's find modulus of vector A. That is modulus of vector A is equal to square root of 2 square 4, 1 square 1, 2 square 4. That is 9. Square root of 9 is 3. That is here, okay, let's find projection vector of vector B on vector A is equal to vector A dot vector B divided by modulus of vector A square, okay, into, not scalar product, into, because it's a scalar quantity, okay, into vector A, okay, into vector A, because here we are going to find projection vector of vector B on A. Okay, therefore here vector A, because this vector is along vector A. Okay, so here what is this one? That is 6 divided by, it is square 3 square 9 into vector A, that is 3 2s are 3 3s are, okay, 2 by 3 into, what is vector A? Vector A is 2i plus j plus 2k. Okay, it is the projection vector of B on vector A. Don't be confused. Projection of a vector is a scalar quantity. What is the formula? Projection vector of A, vector A on vector B is vector A dot vector B divided by modulus of vector B, okay, on vector B, okay. So modulus of vector B. Projection vector of a vector A, vector on vector B is vector A dot vector B divided by modulus of vector B square into vector B, okay. It is the projection vector of a vector A on vector B. Okay. Okay, next question is also write vector B as the sum of a vector along vector A and a vector perpendicular to vector A. So here one more question that is we have to write vector B as the sum of two vectors. What are the two vectors? One vector along vector A and another vector perpendicular to vector A. So here a vector along vector A, that means that is the projection vector. Okay, projection vector of B on vector A, that is the vector along vector A, right? See here. See, look at this diagram. It is the point O. It is vector OB. Okay, vector OB. Vector B is vector OB and OA. It is the vector A. Okay. So here let's join this. Okay. So here see a vector. Our first vector is a vector along vector A. So it is the vector, right? So here this point is here. We know that vector OL is the projection vector. Projection vector of vector B. It is the shadow of the vector B. Right? So vector OL is the projection vector of vector B on vector A or along vector A. Therefore, first vector is nothing but projection vector. What we have got? Projection vector of vector B along vector A is 2 by 3 I plus 2j plus k. Okay, this one it is the projection vector, right? Sorry, it is vector A. Okay, 2i plus j plus 2k. Now here it is the first vector. Second vector is nothing but perpendicular vector. Which is the perpendicular vector to vector A? See, vector LB. Vector LB is perpendicular to vector A. So how to find this vector? See, by the triangular law of vector addition, we can write vector OB is equal to vector OL plus vector OB, right? By triangular law of vector addition. Okay. So here we need to find vector LB. Okay. Vector LB. So it is the vector. Okay. So how to find? Vector LB is equal to vector OB minus vector OL. What is vector OB? That is nothing but vector B. Okay. So here vector OB is vector OB, that is vector B. I plus 2j plus k minus vector OL. What is vector OL? That is nothing but projection vector. Projection vector of B vector on vector A. That is 2 by 3 2i plus j plus 2k. See, here we have got two vectors. So now directly we can write vector B is equal to, you just write vector B is equal to sum of these two vectors. One vector is this one, that is projection vector, that is 2 by 3 2i plus j plus 2k plus here one more vector, that is the vector perpendicular to vector A. So I plus 2j plus k minus 2 by 3 2i plus j plus 2k. Okay, so it is the answer.